Question 6, 10 marks altogether, coordinate geometry. So we have here a circle C with centre A at 7, 5. We have the line L with equation y equals 2x add 1, which is a tangent to the circle at P as shown in figure 3. We want to show, for part A, that an equation of the line PA is 2y add x is equal to 17. Okay, so we know this point A has coordinates 7, 5. Now we know the line joining A and P is a radius. So, let's say PA is a radius. Now, L is a tangent. Now, a radius and a tangent are perpendicular when they meet. So, the gradient of L times the gradient of PA is equal to minus 1. So let's write that down. So I'm going to call that ML, gradient of L, times the gradient of PA is equal to minus 1. Now the gradient of L, y equals 2x add 1, is 2. So 2 times the gradient of PA is equal to minus 1. Therefore, the gradient of PA is equal to minus 1/2. Now at this point, we could use y minus y1 is m times x minus x1, or we can use y equals mx plus c. So I'm going to use mx plus c. So we know then, let's go down here where we have more room. So we know then PA is such that y is equal to minus 1/2 x add c. Now we know that when we know a point on this line is the centre of the circle, so when x is 7, y is equal to 5. So we get 5 is equal to minus 7/2 add c. 5 is 10/2, so if we add 7/2, we get 17/2 is equal to c. So we have y is equal to minus 1/2 x add 17 over 2, multiplied through by 2, 2y is minus x add 17, and then finally add the x, 2y add x is equal to 17. Cool. Okay, part B, and for 4 marks, wants us to find an equation for C. So we actually know most of it, but let's just have a recap. So, a circle centered at A, B with radius R as equation x minus a squared add y minus b squared is equal to the radius squared. So, we know the centre of our circle. The only thing that we don't know is the radius. So we know so far C, so C at the moment is x minus 7 squared and y minus 5 squared, and that is equal to r squared. So what we need to do is find the value of r, the length of the radius. So, to do that, we need to know 2 points on this line. So we know one, we know the centre of the circle. What we also need to work out is the coordinates of P. So, we know that P lies on these two lines, L, y equals 2x and 1, and PA, which was 2y and x is equal to 17. So we're going to solve these equations simultaneously. So, we know that y is equal to 2x and 1, so that's L. Now we also know that 2y add x is equal to 17. So I'm going to subtract that x from both sides and get 2y is equal to 17 minus x. Now we're going to call these equations 1 and 2. Now, the top equation tells us what y is. Y is 2x and 1. So I'm just going to use substitution here. I'm going to put y equals 2x and 1 into equation 2. So we're going to get 2 lots, 2x add 1 is equal to 17 minus x. So we're then going to get 4x add 2 is equal to 17 minus x. Add the x, so we get 5x. Add 2 is 17. Take the 2, 5x is 15. So x is equal to 3. Now, x equals 3 would give us y is equal to 2 times 3 and 1, which is 7. So point P has coordinates 3, 7. So now that we know that, we can work out the length of the radius. So this point now is 3, 7. So now we can work out the length of the radius using Pythagoras. So this triangle has a length of 4 and a height of 2. So, using Pythagoras, PA squared is 4 squared add 2 squared. So, PA squared is 20. So remember, PA is our radius, so that means r squared is 20. So r is root 20, but we don't need that. We only need r squared. So the equation of c is x minus 7 squared add y minus 5 squared is equal to 20. Cool. Okay, then for part C, we are told the line with equation y equals 2x add k, where k is not equal to 1, is also a tangent to C. We want to find the value of the constant k. So my initial thought here was to do this simultaneously, substitute y equals 2x add k into the equation of the circle. That would have worked, but there's a nicer way. So what's going to happen then? Y equals 2x add k has exactly the same gradient as y equals 2x add 1. So we can see what's going to happen is the line L is just going to move down. So at the moment it wouldn't be a tangent because it's hitting the circle twice, so it keeps moving down until, there we go, it's now a tangent again. So we can see that k is going to be negative because our y-intercept is way below the x-axis. So circles are incredibly symmetrical. So this next point of intersection is just going to be a diameter away from point P. So how do we get from P to A? Well, P to A is, so we're going from 3 to 7, so we're going 4 across, and then we're going from 7 down to 5, so it's 4 minus 2. Now that is exactly the same vector then as A to, let's call this point Q, and that is exactly the same as A to Q. So Q is going to have coordinates 7 add 4, which is 11, and 5 minus 2, which is 3. Now, we know the equation of this other tangent, y is 2x add k, so when x is 11, y is equal to 3, so we get 3 is equal to 2 times 11, 22, add k, therefore k is equal to 3 minus 22 minus 19. Cool.